Today our topic is duodenum. Before we discuss about the introduction of the small intestine, we will discuss about the duodenum, jejunum and ileum, their basic introduction. Today we will discuss about the detail in the duodenum. That what is the duodenum, structure of duodenum. So in duodenum, we were having four layers. Four layers. Number one is mucosa. This is the innermost layer, and number two is the muscularis externa. After that we are having some mucosa. Then we are having serosa. This is outermost layer, right? Outermost layer. These four layer we have before we have discussed in the stomach. These were the same in the stomach. We have already discussed about their what they release and all about that. But in intestine, there is something different in the cells, in their glands. So that's the difference between. But these names were the same. These four layers were the same in the stomach, right? So we are having something idea about them. First, if we talk about the structure of the duodenum, it is like this. This this is a duodenum, right? In duodenum, some folds are present like this. Some folds are present. This, if we see it's in the inner side, these like folds are present called the pilici sacularis. Pilici circularis. These are innermost. These are present in inner side. If we see on the surface of inner, these are present. These folds are present. That called the pilici circularis. This is a duodenum, and these are. If we magnify these pilici circularis, if we magnify this, it will be like this. If we magnify this, basically these folds are called pilici circularis. Pilici circularis. These folds are called pilici circularis. Basically, this is a mucosa layer. This is a mucosa layer. As I discussed that here we are having innermost layer, that is a mucosa, and these folds are present on the inner side. So these are the pilici circularis. On this side mucosa layer is present. This is a mucosa layer. Now if we see, after that we are having another layers like on that side. Now if we see about this one structure of this mucosa, that what is this. So we will discuss here that this is like this, right? This is like this. This is a mucosa layer in which some foldings are present called the villi. These are the villi. Here we have discussed that this one, these all are the villi. This is a villi. Singular is villus. Singular is villus, but plural is villi. So if we magnify the structure of the villi, so here you can see in villi, on the outer side we are having some cells are present like this. Some cells are present like this called the micro. These are the microvilli. These are the basically these cells are called the tall columnar epithelial cells. In tall columnar epithelial cells, these some foldings are present in tall columnar epithelial cells. Like this is some foldings are present that called the microvilli. This is a villi. This is a villi. But in these cells that are present on the upper side of the villi, that are tall columnar epithelial cells, In this, some foldings are present like this. Some foldings are present that called the microvilli. Basically, these microvilli are known as the finger-like structure. You can see this. This is a suppose it's a villi, and this is a present. This is a microvilli. Microvilli. So this is finger-like structure, right? These are cells. These cells are also known as brush border cells. Brush border cells. You can see here these are like brush structure, right? These are the brush structure you can see here on the upper side. This is a brush like structure, so these are known as the brush border cells. Basically, these brush border cells contain high amount of mitochondria. Why it contain high amount of mitochondria? Because as we know, in intestine there is a we can say absorption process occur in the intestine. So that for that energy is used for the energy we need the mitochondria, because mitochondria are known as the powerhouse of cell that provide the energy. So for the absorption, energy is required. So in these cell, high amount of mitochondria are present. After that, if we discuss more about this, that if we see the whole structure, like we'll see here. You can see here, basically these are the mucosa layer. This is a mucosa layer in which villi are present. These are the villi. These are present in the mucosa, right? This is a mucosa layer. This is a mucosa. After that, this is a submucosa. This is submucosa, and this is a muscularis externa. This is a muscularis externa, and this is a serosa. Now you can see here these are the structure. I am writing here clearly. This is a serosa. This is a muscularis, and this is a submucosa, and this is a mucosa layer. So basically, these are the 4 layers. This is a villi, as I structured before that. This is a villi, as I discussed here, whole structure of the villi. This villi are present in the submucosa, right? After that, this is the innermost layer. This is the innermost layer. After that, we are having submucosa. After mucosa, then we are having muscular. Then we are having serosa. This is the outer. Layer. So these are the 4 layers of the, we can say, of the duodenum. After that, if we talk about more, that if we take the one villi structure like this. So in this one, you can say one gland is present like this. This is a gland present between the every two villi. This is a gland present between every two villi. What is the name of gland? That is the crypts of labor Cohan. This is the name of the gland that is present between every two villi. You can see here there is a villi that are present in the mucosa, right? So this gland will be called as a mucosal gland. Basically, you can see here this is something like hidden. So crypts mean something that is hidden. You can see here this is hidden, like between the two villi, it's hidden like. After that, this is a gland between two villi. After that, their secretion from that coming from one duct, towards the mucosa. The secretion coming from one duct from the mucosa. Basically, the we can say crypts of Leberkorn is an exocrine gland. As we know that what is the exocrine gland? That is with duct. Exocrine gland, which means anything which is with duct. Gland with the duct. Gland with duct is called the exocrine gland. So you can see here with the crypts of Leberkorn gland, there is a duct present, right? That is duct of the crypts of Leberkorn. Secretion of crypts of Leberkorn. After that, if we talk about the submucosa, here in this is the mucosa, that is the villi, and if we talk about here submucosa, one gland is present in submucosa like this. Like this. This is a gland present in the submucosa that called the Brunner's gland. Brunner's gland present in the submucosa. The secretion of Brunner's gland go into the mucosa. Secretion of Brunner's gland present in the submucosa, but its duct opens in the mucosa. Brunner's gland is also the exocrine gland. It is also the exocrine gland that opens in the mucosa where secretion of crypts of Leberkorn is present. As we discussed before, the secretion of crypts of Leberkorn go in the, obviously that is present in the mucosa, that will be in the mucosa. So secretion of Brunner's gland also go in the mucosa. So the secretion of we can say crypts of Leberkorn secretion and the Brunner's gland secretion, these both secretion combine and called as a succus entericus. The secretion of crypts of Leberkorn and the secretion of Brunner's gland that also go from the duct of the crypts of Leberkorn, as we discussed before that duct is present on the in the we can say crypts of Leberkorn. So the Brunner's gland secretion will also go from that duct. So the Brunner's gland and the crypts of Leberkorn, both secretion mix together in the mucosa and known as the succus entericus. So secretion called the succus entericus. After that, if we talk about more that we have discussed before here. So the Brunner's gland is known as the mucosal gland. Why? Because its secretion go in the mucosa, right? After that, Brunner's gland releases some enzymes. It releases some enzymes, mucus. It releases enzymes, mucus, and water. Sorry, one point I have remained that for this one crypts of Leberkorn, what it will release, it will release the mucus. So the Brunner's gland will release some enzymes, mucus, and the water. After that, we are having an important point that we were having the gland that for the crypts of Leberkorn, right? So the crypts of Leberkorn, the cells are present in that secretion. Cells are present in that gland. Cells are present in gland. Now some cells are present in the gland. If we talk about cells, number one, goblet cells are present. Goblet cells are present. These were also present in the stomach, as we have discussed before. So goblet cells are also known as the mucus cells. Mucus cells that secrete the mucus that is helpful in the lubrication lipid. These all things we have discussed in the stomach before that, right? So after that, goblet cell will release mucus and releases bicarbonate ions. It will release mucus and releases some bicarbonate ions. Mucus to neutralize the effect of HCl. Now here is one important point. What is the pH of duodenum? That is a 8. pH is a pH of duodenum. So if we talk about another cell number 2, that is the endocrine cells. Endocrine cells. What are these? Basically, these are also known as enteromeraphin cells. Enteromeraphin cells. These are also known as enteromeraphin cells that releases hormone called the histamine. It releases hormone called histamine. Basically, it releases in the blood. Histamine will released in the blood. Basically, histamine will work in the GI motility. Now, what is GI motility? If we talk about the GI motility, GI means gastrointestinal, and if we talk about motility, that means the contraction. So what does that mean? That the contraction of the muscles of the gastrointestinal tube. Contraction of muscles of gastrointestinal tube. So that was the GI motility. After that, number third cells we are having that the Argentina fin cells. These Argentina fin cells and goblet cell we have also discussed in the stomach before. So as we all know, Argentina fin cells will secrete serotonin. It will secrete serotonin, that is a neurotransmitter. After that, we are having number 4th cells, that is a Panth cells. Panth cells. Now, what are the Panth cells? Basically, they releases some enzymes. Some local enzymes. What I mean by local enzyme, that why local enzyme, these enzymes are called the local enzyme. Why? Because these are also present in the pancreas, that's why. After the number 5 cells we are having, that we have discussed also in the stomach, that are the basal cells. What are the basal cells? As we all know that these are the precursor cells. There is formation of the new cells. These are precursor cells. Before cursor cells, formation of the new cells. After that, duodenum is divided into, if we talk about the divide on the basis of the functional structure, it divided into 2 parts. Number 1, the exocrine part, and then number 2 is the endocrine part. First of all, if we talk about the exocrine, what is meant by exocrine? As we all know that exocrine means with the duct and endo means without duct. In exocrine part, enzymes are released, and in endocrine, hormones are released. First of all, if we talk about the exocrine, as we all know, we discussed about the Krebs of Lebercon, that was also exocrine, that released the mucus that is helpful in the lubrication, right? After that, it releases some enzyme peptidases. It releases peptidases. These are the enzymes that break down the proteins, right? So we are having two types of peptidases, that is exo and endo. We will discuss this later, what will be the exo and endo. So this releases some enzyme. If we talk about the local enzyme, if we talk about the local enzymes, what will be the local enzymes like amylase? If amylase is present in pancreas, that will be known as a pancreatic amylase. And then there is lipase. What is the work of amylase? As we all know, it will convert a starch into the maltose, and lipase, it will convert lipids into the 3 fat acids and 1 glycerol molecule. After that, we are having lactase that convert lactose into the 1 glucose molecule and 1 galactose molecule. After that, we are having sucrase, right, that converts sucrose into the 1 glucose molecule and 1 fructose molecule. After that, maltase that converts maltose into 1 glucose, 1 sucrose or 1 fructose molecules. So these are the local enzymes basically. After that, we will discuss another point. Another enzyme, that is an enterokinase. This is an enzyme. Basically, this is known as a key enzyme. Basically, enterokinase is released by cells called the enterocytes. It is released by cells, enterocytes, that are present in the duodenum. These cells are present in duodenum. Enterocytes. Basically, enterocytes are absorptive cells. These are the absorptive cells. After that, another part, if we talk about, these were all about the exocrine part. Now if we talk about the endocrine part. In endocrine part, as we discussed before, that it releases some hormones, right? If we talk about number 1 hormone, that is the cholecystokinin. What is the cholecystokinin? CCK. Basically, it is a neural hormone. What is the neural hormone? That it will stimulate something, right? So basically, cholecystokinin will stimulate the gallbladder. It will stimulate gallbladder. To release their secretion. Basically, cholecystokinin is released by eye cells. These are the cells that are present in the duodenum. So cholecystokinin CCK is released by the eye cells. When acidic chyme enters in the duodenum, then eye cells secrete cholecystokinin, so that cholecystokinin will stimulate the gallbladder to release their secretion and release their carbonate ions. Number 2, we are having, that is a secretin. Basically, secretin is released by the S cells. These are also present in the duodenum, S cells. So basically, secretin will, you can say, it will stimulate. It will also stimulate, we can say secretin is responsible for stimulate of the pancreas to release bicarbonate ions. And water. Secretin is responsible to release bicarbonate ions from the pancreas. So it will, you can say, it will Stimulate the pancreas. Basically, secretin is released when pH drops to 4, then secretin is released. Why? When pH drops to 4 in any condition in duodenum, so the secretin is released by the S cells to stimulate the pancreas to release their bicarbonate ion so that pH get maintained. After that we are having number 3, we are having G cells. These are the cells that we have discussed in the in the stomach also. These are present in the pyloric end of the stomach. These are known as the gastrin cells. Gastrin cells, basically it will stimulate the pancreas and gallbladder. After that we are having K cells. What is the work of K cells? Basically these are present in the duodenum that release the gastric inhibitory peptide, GIP. Gastric inhibitory peptide, it will shut down the secretion of gastric juice or gastrin. So basically GIP, gastric that was a gastric inhibitory peptide, it will shut down the gastric secretion is in the stomach if the secretion is more. So that was all about the, you can say, duodenum. After that we will discuss about the pancreas. Then we will discuss more towards the small intestine.